Okay. Yeah, I hope you're done copying.
Yeah.
Okay, so yeah, so one thing I want to actually mention that if the resultant force if is equal to 0 Newton, that the body is either stationary or moving with constant velocity. Okay. Yeah, constant velocity means 0 acceleration. A parachutist falls to the ground. And terminal velocity I actually gave you the answer of the question. I'm sorry. Yeah, so when a parachutist is falling to the ground at terminal velocity, it actually means that his weight is equal to the upward force that is acting on him due to the air resistance. Okay, and that's why he reached the terminal velocity. That means his acceleration is 0. Okay. So let's say that's him, and that's the air resistance. When these two are equal, the resultant force is 0. All right. Yeah, if the force wasn't 0, I mean the resultant force was not 0 Newton, then the stationary body if the body is stationary, it will start moving. And if a body is already moving, then it will change its velocity, of course. Okay.
Yeah. So it is only zero because terminal velocity, right? And the upward air resistance and the downward weight is equal to each other.
Yeah, so because the upward resistance and the downward weight, they're equal to each other in magnitude, not the direction, I mean. That's why the resultant force is zero. This body right here, it's not experiencing any sort of force. That's why the acceleration is zero. So the velocity became constant. That's where um, the parachutist reaches this terminal velocity. Terminal velocity is the constant velocity that reaches after someone jumps. Okay.
Yeah.
All right. Now friction. This is another sort of force that we will learn in details. Okay. So what is friction? So it's the force which opposes the motion when objects slide over each other. I would say it's a wrong definition, to be honest. It doesn't have to be an object. Um, for example, friction in air or any sort of fluid. It can happen in any sort of fluid. Friction in the air is basically air resistance. Okay. So the friction is basically a force that tries to oppose the motion of an object. Okay. I would say don't try to write this. This is a wrong interpretation. Opposes the motion of an object. Okay. Now, what are the advantages of friction and what are the disadvantages? Pros and cons. Okay. So some pros and cons. Yeah, due to friction, we're able to walk on roads. So walking on roads that got easier due to friction. Friction, for example, is needed in brake pads and wheels of cars. So needed needed in wheels of cars and bicycles. Yeah, that's it. Actually, there are no more pros. Um, what about cons? It wears down machineries, wears down moving parts of machineries. Um, yeah, for example, if an object is moving on a rough surface, due to friction, it needs more energy to move, okay, compared to a smooth surface. All right, that's it. I don't think there's anything else to write. Now, are there ways to overcome friction or to reduce friction? Yes. Number one is use lubricant for, it could be oil or, I don't know, grease or graphite for moving parts. Use ball bearings between moving surfaces. Or you could say have smooth surfaces, so a surface can be made glossy and stuff just to reduce friction. Okay, that's it. These three are the different ways to reduce friction. Now let's do an example. Okay. Now, I mentioned here that it lies on a rough surface. It basically means that I'm telling you that friction is present. If they actually say, okay, lies on a smooth surface, that means you can actually ignore friction. But here you have to take into account the friction, okay? A constant F1 force of 12 Newton acts on the object. The frictional force F acting on the object is 2 Newton. Find the acceleration of the object. It's quite simple. If you want, I can also draw the diagram. Let's say this is the rough surface. This is the object. This is F1. And obviously, you can do the rest.
Abu, is it 1/5?
What, the acceleration?
Yeah.
Not really.
We have to subtract 2 from 12, right? Because
Yes.
it's friction. And then we don't know the mass here, right?
Did I not give you the mass?
Is it 15 Newton is the force, but it says an object weighing 15 Newtons.
Yeah, so that's where the clue lies. You can use, I'm just going to give you a hint. You can use 10 G, sorry. 10 meter per second square for G. Okay, let's do this together. So obviously,
sorry, for mass, we can just use the weight equals to mg formula, right?
yes, so the weight is equal to mg. So that's where you can find mass.
Is it 2?
Yes.
Meter per second square.
Yes. So I'm quickly going to finish this myself as well. So the friction, which is small f, this is acting on the opposite side of F1. So F1 is what? 12 Newton. I'm sorry, that should be in black. So this one is 12 Newton, and the friction is given as 2 Newton. And you also have to draw your weight, which is 50 Newton. Now from weight, we can find the mass. So that is 50 divided by 10. This is this. Now, you have to remember that in this formula, whatever you get, this is not G. This is going to be kg, okay? So that gives you 5 kilogram, okay? And then using your formula, you have F equals to ma. So the resultant force, this one is the resultant force. Resultant force is 12 minus 2 Newton, 5 kilogram times acceleration. So if you try to find the acceleration, that is 10 Newton, 5 kilograms, 2 meter per second square. Okay.
Yeah.
All right, now you actually have to mention the direction of this acceleration. It's towards this side. Okay.
Am I allowed to show the like the arrow, or do I have to write it towards the right? Or
Yeah, you can also write that towards the right. Or maybe you can also mention that the same direction as F1. Everything is fine.
then copy.
Okay. The last thing for today, another example, and then we're done. But I cannot draw this one. I'm just going to give you a picture. By the way, and a question, an interesting one, actually. So an object is moving on a circular path and it has a constant speed. Is it accelerating?
But it isn't accelerating, right?
Yeah, that's the thing. For circular motion, you'll see that, just imagine this object and it is like moving like this. So at every turn, it's changing its direction, right? And like we know, velocity is nothing without the direction. Velocity has a magnitude and also a direction.
Yeah.
Even though the magnitude is the same, because the direction is changing, it means it is accelerating. Okay, because acceleration means the change in velocity, right? Because the direction of the velocity is changing, that means the velocity is actually changing, so it is accelerating. I know it's a
So
bit
if the speed is constant, doesn't the magnitude is constant? If
exact.
there's a change in direction, it means it's accelerating.
Yes, that's why I asked this question, because you need to know that even if the direction is changing but the magnitude is the same, it means the velocity changed. So it means that it is accelerating. Okay.
Yeah.
So the answer would be yes, its velocity keeps changing. Now, you can say constant speed, but not constant velocity. Okay. Changing because direction keeps changing. Hence, there is a resultant force acting on the object. Okay. Now, I think you have a circular motion in your syllabus. I'll check again, but I'm just gonna tell you that in circular motion, the resultant force is acting towards the center of the circle. So as the object is moving, its resultant force, the direction of its resultant force, it's still towards the circle, towards the center of the circle. Okay.
Yeah.
This is known as the centrifugal force. I will talk about this later, but I'll first check if you have this in your syllabus. And this force is the one that is actually making the object change direction. Okay, it is not changing its magnitude, but yes, it is changing its direction. Okay.
Yeah.
All right. Yeah, I was about to give you another example before I leave. Okay. Try this, and then I will help you.
The first one is weight and air resistance, right?
Yes. So the first one, yes, P is the air resistance, and Q is the weight. Explain why
The
P is
second
acting upward.
Yeah, so it is because to prevent the object, to prevent the person from going down.
Yeah, so in other words, air resistance, which is also a form of friction, it opposes the motion of the skydiver. Okay,
Yeah.
it opposes the motion of the skydiver.
Yeah.
So that's why, since the skydiver is falling vertically downwards, the air resistance will act vertically upwards. Okay. All right.
Yeah.
So this is the answer for number 2. Now see, when the
Another question. In the question of C, it says the forces P and Q are unbalanced. Like,
yeah.
the difference between unbalanced and balanced is when the forces are balanced, there is no acceleration, right?
Yeah, so the forces, when the forces are balanced, it means the resultant force is 0. So there is
Yeah.
no acceleration. And unbalanced means they're not equal. Okay. All right. When the skydiver starts to fall from rest, that's when the forces P and Q are unbalanced. But as time goes on, it will actually become balanced at a point. Okay. That's when the terminal
Yeah.
velocity is reached. So find P and Q at time t equals to 0 seconds. All right, so P, which is actually air resistance, it is 0 at the very beginning. Okay, so at
Yeah.
t equals to 0, it is actually 0. And Q, we already know that is just the weight, which is mg. Okay, and we know from the question that the skydiver is 60 kilograms times 10, that is 600 Newton. Okay.
Yeah.
Now, find P and Q when the velocity of the skydiver is uniform. See, so now the skydiver has actually reached the terminal velocity. That means the acceleration is 0. Now P and Q are balanced. Okay, they're the same. So P is right now 600 nanometer. Uh, why am I saying nanometer? Newton.
Yeah. So both the weight, both P and Q are equal.
Yeah, so right now P and Q are equal and the resultant force is 0. So yeah, Q will stay the same throughout. The P, which is air resistance, will keep changing. Okay.
Yeah.
Last question. Describe in terms of the forces acting on the skydiver why the velocity of the skydiver increases before reaching terminal velocity. Well,
Isn't it because it's overcoming the air resistance?
Yeah, so you have to say that, before reaching the terminal velocity, obviously the P is not yet, is less than the Q, okay? Because the P is starting to increase, but at the beginning, it's not equal to Q. So the resultant force is actually acting downwards. This means the body, the skydiver, is accelerating downwards, okay, because of this Q, because of this downward resultant force. I hope that's clear.
Could you write the answer? That's
Yeah, sure. So when, let me say at the beginning. I think now it's clear, right?
Yeah.
Okay, this is the answer for number 3. So at the beginning, obviously, P is less than Q. So if you try to find the resultant force, which is the difference between these two forces, so Q minus P, it is actually greater than 0, okay? So that means the resultant force is actually acting downwards. So due to this resultant force, like we already know F equals to ma. Because of this resultant force, we will have an acceleration, which also acts downwards because the resultant force is acting downwards. And that's why the velocity will keep increasing because there is an acceleration. But once we reach the point where P is equal to Q, that means there is no difference anymore. The resultant force is 0, okay? So this becomes 0, acceleration becomes 0. That means the body is not accelerating. The velocity is going to be constant. Okay, and that constant velocity is known as the terminal velocity. Okay, so some of the points that you have to remember are that when something is falling, number one thing is if the air resistance is not negligible, you have to remember that jump করার সাথে সাথে air resistance weight এর সমান হয় না। প্রথমে air resistance 0 থাকে, তারপর আস্তে আস্তে air resistance বাড়তে থাকে, and at a point, at a certain point, it reaches the value of the weight, so it counterbalances it, and that's when the resultant force is 0, and এর জন্য our body টা accelerate করে না, তখন it reaches the terminal velocity. Okay, but at the beginning it is accelerating. And let's say on the moon, or if the question specifically says ignore air resistance, the body will constantly accelerate downwards. Okay, because there's nothing to counteract it. All right, done for today. See you next class. Bye.